So we're going to talk for just a minute about graphing logs. And there's a couple things you need to understand. Logs look kind of funny sometimes. What they will do, logarithms have an asymptote, which if you remember, an asymptote is just an invisible kind of barrier that keeps the graph. It hugs real close, but it never actually crosses. And then what that graph is going to do is come over like this. And so sometimes students can have a little bit of a difficult time graphing them, but I want to walk you through a couple different methods that you can use to graph, and then some of the kind of analysis that we can do with it to help you out. So I'm going to start with, let's say the log base, let's say we want to graph log base 3 of x. So what's going to happen is I'm going to show you how to graph it on your calculator first. So if you have a graphing calculator, if you hit the y equals button, which is the button right here, I don't know if you can see where I'm circling here, but right at the very, very top left. And what you want to do is you're going to have to use that change of base formula, because remember, if you think back to the previous lesson, our calculator is only in a base of 10. So whenever I type this in, I'm going to have to do log of x divided by the log of 3 when I graph this. So I'm going to type log x divided by log 3. And if you just hit graph, and maybe yours doesn't show up right away, you might want to do a zoom number 6 for a standard window. And you can adjust that window as you need. So there's a couple things I want to look at. And if you look closely at this graph, it looks like, and actually let me come to another page so we got plenty of room. Again, this is log base 3 of x. We have an asymptote, which you can't see on my graph, and that's okay. I'm going to show you in just a minute what we do. We can tell. Okay. So, looking at this graph, and if you need to zoom in some, by all means, I'm going to take this minimum, actually let's go -1 out to maybe 5, and maybe -5 to 5, just to kind of zoom in a little bit and let you see the graph a little bit better. Alright, so the graph itself, and it may be, let me see if I can, the graph itself here is actually moving down, and it's hugging this axis, even though you can't really tell. So that tells me that there is an asymptote, and all log functions are going to have vertical asymptotes. So this tells me that my asymptote is right there at the origin. So maybe I'm asked, oh my goodness, my screen's messed up, for an asymptote, and that equation would be x equals 0. And we'll look at one that kind of shifts in just a minute so that you can see a little clearer. It also has an intercept, an x-intercept, which again is where it's crossing the x-axis. So if you go back to your calculator, if you hit the button that says second, and then the trace button, because above trace in blue it says calculate, we want to come here and find the 0, which is number 2. And left bound is telling me to get on the left side, because what I'm doing is I'm calculating this exact point where it crosses the x-axis. I'll hit enter, then right bound, so I'll get on the right side of where it crosses, and I'll hit enter, and it says, do you want me to guess? Yep, I do. So my 0 coordinates are 1, 0. That means it crosses the x-axis at 1, 0. Looking for a minute at domain and range, and a lot of students have a hard time with domain and range. Domain is the compilation of all your x values that your graph can be. So if you look at the graph left to right, I always start with the smallest up to the biggest. The smallest the graph ever gets, if you notice, it's getting close to, this is my x-axis, remember, it's getting close to 0, but it never touches it. So I use a parenthesis to indicate that it doesn't include 0, but it gets really close, but then x can get just as big as I want it. I can continue to go right forever and ever and ever. The range, if you look, there's nothing bounding the range. It goes down forever because range is my y. It describes all these y values. It goes down forever as well as going up forever. There's nothing that's keeping it from going up or down. So my range is going to be negative infinity to infinity. One last piece that tends to give students a hard time is in behavior. So, oh my goodness, let me talk to you just a second about in behavior. So in behavior does exactly what it says it does. It describes the ends of the graphs. Okay, so I have two ends of the graphs. I have 1 and I have 2. So I'm going to describe both of those. I'm going to just come over here and I'm going to write EB for in behavior. Now, I want you to look, again, this is my x-axis. So as x, and this little arrow means approaches, positive infinity. So as x gets really, really big, so the further over right you go, what happens with the graph? Does it go up? Does it go down? Does it stay at one point? And I hope you can see that it's kind of creeping up. So it's just going to keep going up and up and up. So that tells me that as x goes up, so does y. Okay? Now, this end's a little bit harder to describe because I can't say, normally I would say as x approaches negative infinity, but here it doesn't approach negative infinity. It gets closer and closer to this asymptote value, which is 0. So as x gets closer and closer to 0, that graph goes down really, really, really fast. So that tells me that y approaches negative infinity. Now, I hope you can use all these tools to analyze on your own, given a graph. Let's say that, however, you might not have a graphing calculator. There is a site, Desmos.com, where you can come and you can type in your equation. So we'll do that same log x divided by log 3. And here, if you look, and this is a nice site because you can kind of click on the points you want. It'll give you the coordinates. There's not quite as much calculating as with the TI, but they're both very, very easy ways to graph. I think the Desmos might be a little more user-friendly. You can, and I've got a touch screen right now, so I can kind of drag it around and look, and I can zoom in and I can zoom out. Just make sure you have to change that base in here as well, and we'd have to do the log x divided by log 3.